In this video series, I work through a math problem or problems each video. When we add and or subtract expressions with radicals, we treat radicals much like terms that we used to work in the earlier videos. Expressions with radicals are considered alike if the radicands and the index are the same. We do have to watch out since some radicands, even when initially written with different numbers, may be rewritten to match up. Let's take a look at the given problem. We need to simplify the expression 3 multiplied by the square root of 8 plus 3 multiplied by the square root of 27 plus 5 times the square root of 2 plus the square root of 25. If we compare the four radicands 8, 27, 2, and 25, since now these radicands match up, it initially appears as if we can't really simplify this expression further. But let's take these square roots individually and see if we can simplify them first. 8 is equal to 4 times 2, and 27 is equal to 9 times 3. And 25, of course, is a perfect square. So we first move the 4 out of the first square root, and when we do, we get 2, and 3 times 2 is equal to 6, and we're left with the square root of 2 inside. Next, square root of 9 is equal to 3, and 3 times 3 is equal to 9, and we multiply that by the square root of 3. The next term we can't simplify, so we'll just copy that, 5 multiplied by the square root of 2, and finally the square root of 25 is equal to 5. If we now compare the three remaining radicands, we see that the first radicand and the second radicand is the same. So we can combine the first and the third terms together, and that gives us 11 multiplied by the square root of 2. Then we just copy what's left. 9 times the square root of 3 and 5. And since we can't simplify this expression any further, the simplified expression is 11 multiplied by the square root of 2 plus 9 multiplied by the square root of 3 plus 5.